Okay, so this is lecture 9, continuing right along. I've got 2 more topics to talk about we have to get through before we leave. We're going to get through cost estimating, and we are also going to get through, no, it's got to wait. It has to wait. I already started.
No.
Oh.
I want to that.
Oh, okay. I'm going to talk about costing and estimating, and then I am also going to cover software architecture. So those are the 2 topics we have to get through before the end of the day. Which is, we're not doing too bad on it, except for all the interruptions with the test stuff. Alright, so predicting resources required. Objective, introduce fundamentals of software costing and pricing. And, which, you know, I'm not going to cover the Cosimo model. I didn't cover it, actually, for the day group. So, actually, the day group. This is like the night group. This is the weekend group versus the weekday group. So, describe 3 of the metrics of software productivity assessment. And basically what I'm going to do is introduce you to the challenge, because software is a business, but at the same token, it's also a unique animal in itself because it's really hard to determine how long is it going to take to build something. What is it really going to cost to build something? Because we have resources, we have time, we have a bunch of stuff that's unpredictable. So in terms of productivity, estimating, and algorithms, so in terms of the fundamental estimation question is how much effort is required to complete an activity? You know, some people think, well, it depends on the skill of the programmer. Not really. It's the complexity of the program, and it is how well the requirements are actually understood. In fact, some of the easiest programs are the hardest to write if you don't actually know what the user wants. You don't know what you're writing. How many calendar time days is needed to complete the activity? What's the cost of the activity? So if you're running a business, one of the cost estimate is the most important factor, essentially, because what you're looking at is how long is it going to take and what is it going to cost. And if you're manufacturing a product, you already know what your cost of materials are. You know how long it takes to build something. So the battle here is, kind of a toss-up between how much time and energy do you want to put into it, and is it junk science, and are you really coming out with something? The Cosimo model, which I'm not going to cover, actually kind of looks at previous software development efforts and it based future costs off of previous experiences. And in order to do that, you have to have those previous experiences. And then you have to be able to come up with formulas. And the formulas have to be correct. The problem with the model is the formulas are outdated. And you can't use, it's been around since the 80s, 1980s. You can't use those old estimates anymore. Programming languages are different. Natures of software applications are much different. So it doesn't really hold true. Total cost of the activity, estimated scheduling. So, you know, everything is always over budget and over time, because time is also another factor. So software cost components. Well, we have the software, but we also have underlying hardware that we might be dealing with. So we have to worry about hardware, travel and training costs, effort costs as well. And these are some of the cost categories that we're looking at. Take into account. So estimates are made to discover the cost. So it's all about estimating. Because we don't know the cost. We're flipping a coin for the most part. So if we come up with estimates, we can discover, hopefully, and apply a science to it. So there's no simple relationship between the development cost and the price charged to the customer normally. In fact, this is the interesting thing is when you go to somebody and say, how much is it going to cost for you to build me an application? And the application is going to do, what's wrong? The application, can you catch?
Yeah. Sure.
I don't knock any eyes out. Okay. Yeah. The application's going to do
I started writing again.
X, Y, Z, and the application's going to interface with this and with that. And people just come up with numbers. And you often wonder, where is this number coming from? Oh, $5,000. It's like, how in the world can you do that accurately? So I'm always skeptical of people who don't, like, at least take the stuff back to their office and write me up a quote, send it to me in email, or at least come up with some sort of a contract or some sort of a, which is interesting. In fact, you get these people all the time, usually with Craigslist ads. You say, you know, this is what I want, can you build it for me? And they reply, oh yeah, $500, 2 weeks. Oh, wow. Good, I'll take it. Well, usually what ends up happening, though, is they won't deliver, and they'll ask for the payment up front, or they'll ask for the payment halfway in the middle, and that's just a scam right there. There's no simple relationship. So the broader the organization, economic, political, business considerations, that definitely influences the charged price sometimes. And so here's some pricing factors. And this is what actually kind of makes software development kind of an interesting industry or business, is because it's not really based upon traditional business pricing cost structures. Are you going to look at market opportunity? Are you going to be the first to market? Who else is selling the program? Can you sell the program to other people? Cost of estimate might have some uncertainty to it. Contractual terms, requirements that might change. Financial health of the company might be an interesting factor as well. So in terms of programmer productivity, because what ends up happening to do is you have to put a price on the programmers and say, well, what about this experienced guy? He's going to cost more than this inexperienced guy. And how many lines of code can that person write? And this is how it ended up starting out. In the beginning, people used to count lines of code and said, well, 20 lines of code is worth such and such money. And then people, lines of code is like comments, can you write? And anyway, programming styles influence the number of lines of code that are written. Programming the languages influence that as well. Different languages have different amount. You can't use that. In fact, it came out as being a little bad estimate. So you can measure the rate at which the individual engineer is involved in the software development project associated with documentation. Not quality-oriented through quality assurance. In fact, it promotes bad programming, promotes extensive writing of code that's not necessary. If you want to measure useful functionality produced per time unit, you can actually, instead of looking at programmer productivity, you can look at maybe size measurements based on the output of the software process, maybe the lines delivered, object code instructions. Sometimes you can count the number of objects, you can count the number of procedures. Function point analysis also works, plays a part in that. In terms of the measurement, estimating the size of the measure, estimating the total number of programmers per month. How many programmers do you think you need? So what ends up happening, and I'll tell you the bottom line conclusion of this entire lecture, experience, experience, experience. It's kind of like the real estate market is location, location, location. Software engineering is experience, experience, experience. The more experience you have, the more you know. You base everything off of the experiences that you've had. That's the science behind the entire concept. But how valid is it? It's pretty valid. It's like location, location, location for real estate people. Because if you don't know, you don't have any experience, you don't know how many programmers it's going to take or how long it's going to take. So that always surprises me when the brand new people come out with estimates. It's like, what do you mean? Other people, they're basing it off on other people's experiences normally. So estimating contractor productivity, number of programmers, lines of code. Nobody knows how bad this is. Everybody knows how bad this is, actually. So nobody does this anymore. In terms of comparison, the lower level of language, the more productive the programmer. The more verbose the programmer, the higher the productivity. That's what ends up happening in terms of the lines of code and productivity comparisons. High and low level languages, we know, have different characteristics associated to them. So analysis, design, coding, validation. Or a high level analysis, design, coding, validation. Kind of the same, but it takes less time, or it takes more time. So we have variances in different languages, which makes counting lines of code, or even development times a bit unrealistic in terms of the comparison. This still works. Function point analysis. So a function point, this probably answers your question for the midterm. So the function point analysis, you're taking it. This is so unkosher. Never again am I doing this. That's it. No more. Learned my lesson on this one. Alright, function points based on a combination of program characteristics. We have external, internal, and I'm not even going to give you the answer actually. I'm purposely not going to give it to you. The weight is associated with each one of the factors. So what we're looking at is coming up with a count. And upon the count, we're determining the difficulty. And depending upon the difficulty, we're putting a price value on it. So some programs naturally have more function points than others. And the function points could be modules, they could be classes, objects in the system. They're units. So the function point count is computed by multiplying the raw count of the weight and summing up all the values. And what we're looking at in terms of the language, we can actually put a function point in the lines of code as well. And we're coming up with a quantitative way of measuring, essentially, the software. So we can put a price value on it, and we can put an estimate on it. So.
But what is
A function point could be a module. It can be, in fact, here's an object point to get into the concept. A function point could be a class. How many classes are in the system? 5 classes, 5 function points. Versus a program that has 20 function point or 20 classes in it. A function point can also be an internal or an external input. It can also be an algorithm. So it's a quantifiable piece of the code that you're counting. And you're classifying function points in different categories normally. And you're adding them all up. So it actually, what it does is it gives you the complexity of the measurement of the functionality. How much functionality is occurring. An accounting program isn't going to have as many as a point of sale program, actually. Because point of sale has got more inputs, more outputs, more calculations, more procedures going on. Accounting program, you get, accounts receivable, accounts, you have the reports and things that you're printing out. You really just have a database of transactions that you're keeping track of. Not as many transactions are occurring, usually. So you may not necessarily have as many. And the function point definition is just functionality. A function point is going to vary depending upon the programming language that you're using. And it's very programming language specific. So it could be a module, it could be a unit, it could be a file. It could be all sorts of different things by concept.
Is it like, when each client tells us about the requirement, we understand the requirement, then we come up with the design, then we come up with a, architectural thing that, this is how the system is going to look like.
Yep.
And then then we'll make then we calculate that, how many functionalities will be there, and based upon those functionalities, we will be counting the function points.
Yes.
Is it like that?
Yep. So once you come up with the architectural design of the system, you can actually do a pre-estimate on the function points. You can also do the function points on pseudocode or on the design that you've created. In Software Engineering 1, we took requirement spec, did the analysis, turned it into the design document. At that point, you can take the design document and do a function point analysis on it. And the function point analysis would say, for this particular design, it's going to take this number of function points and then make an estimate on how many man hours of labor, how many programmers you probably do, depending upon the time constraints, and how much money it's going to cost you, based on the cost per programmer and resources.
Does it mean that higher the function point number, higher the complexity of the project?
Higher the cost.
And higher the time?
Yep, higher everything.
But it's like sometimes, there are two situations. In one situation, we have a case where we have a fixed budget project. Client comes and he says that, I have a fixed budget project. So
Well, that's the worst deal.
yeah,
I have a fixed price, but here's what I want. So sometimes it's a good deal for you, sometimes it's a good deal for them.
But
I wouldn't even take I would not even take a project like that.
But
I have $3,000 to spend. This is what I want. It's either if you're okay with that, then do it. If you're not, there's no flexibility. There's nothing.
But on that only I want to understand. Say client comes and he says that this much is my budget, and if you want to take this project, you can take it up.
Yeah.
And definitely the person or the company who will be who is interested in developing the system, they will take some time to analyze the things. They will think about.
And then they'll come back and they'll say, "Well, your budget is $3,000. It's really only going to cost me $2,000. Yeah, I'll take it, and I'll charge you $3,000." Or you come back and say, "Well, this is really a $5,000 project. No, not going to take it unless you want to give me $5,000."
But in that time, it's like because understanding the requirement is a big task, and obviously they cannot take that much time.
It's lost money. It's lost revenue. But think about it. It's part of your investment. Because the more time you spend up front deciding whether or not you should take that project, the lower the risk of failure, and the lower the risk of actually having a bigger loss. It's kind of like how people are afraid to stop a project that's already started because they've already invested this much time, they've already invested this much money into it. Well, I can't stop now, I'm going to go forever. But they just keep wasting and wasting and wasting and wasting more money over and over again until eventually the thing's going to fail. So you could just cut your losses buying a brand new car or something like that. Enjoy the car. And just toss in the rest of the loss in front of the loss. Because eventually it's going to fail. Same kind of theory. So you get a project guy, customer comes to you and says, I have $3,000, I want you to build this program for me. So you go home, you spend 12 hours, 2 days, 3 days. You're not getting paid for this, you're not going to get paid for this time, especially if you say no. But it might save you, because the project might cost you $5,000, the customer's only going to pay you $3,000. You're going to get a $2,000 loss if you deliver this thing. If you sign on a dotted line, you say I'm going to deliver it, and you don't deliver it, you're going to go to court, you're going to have to pay court fees. You're going to have to end up paying for it anyway. It's a bad deal all the way around. But if you don't spend the 12, if you do that without investing the 12 hours or the 2 or 3 days of time that you're not going to get paid for. So worst case scenario, you go home, you spend a week researching this, putting it together. Half these guys actually put the design already together, because until you have the design, how do you know how complex this thing is going to be? They'll give me all your document, give me everything. They'll practically have the thing built, then they'll give you a price. That's the best way of doing it. In fact, PCB board guys do this all the time. They'll make a prototype of the board. They'll actually put together, make sure your schematic actually works. Proof of concept, board design, they get all the parts they know, everything they need. Then they'll give you a quote for 500 of them or something.
But it won't be possible to do it so fast.
Oh, it is possible.
Only a prototype?
If you're not going to build the whole thing, no. You're not going to finish the project. You're just going to design it.
So even the function point analysis could be done by that time?
Function points are done on the design. They're not done on the finished product anyway. It's your design. Your architectural design, when we're talking about next, it's your design document that's going to give you your function point analysis. Because you're going to know how many functions you're going to have. You're going to know how you're going to put it together. And you're counting components. That's what you're doing. You don't have to know the components don't have to be built to count them. But yeah, no, actually, it's very typical for programs that have half of it written already before they even take on the contract. And if you say no, okay, yeah, you wasted your 3 days or something. But you learned from it. And you can use it for experience for the next project that comes around. And who knows, maybe the next guy who comes around wants the same kind of application, but they're willing to pay more. So then you already know how to build it. So. Objects are same as functions, but they're objects. Object-oriented languages uses object points instead. Object point estimation is done the same way. It's easier to estimate specifically. In fact, object points are more accurate because objects are classes. And the number of classes depends on the company is going to determine your complexity. So you can say, oh, this looks like a 5 class, this looks like a 10 class, a 20 class. And we'll look at classes in a few minutes and objects. And all you do is count it all up. Then put some blanket. In fact, the blanket that you put on there, and this is what this slide's all about, depends. You have to make this number up. And through experience, you adjust the number. So real-time embedded system, I don't know, 40 to 160 lines of code per programmer per month. Who knows if that's realistic or not. You come up with your own specs. It's like any contractor comes up with their own specs. To build the foundation, or I'm going to build a swimming pool, so I need to dig a hole, I need to lay the cement. You have all of it already pre-calculated out from previous jobs that you've done. And you look at that and go, that's a $10,000 job. Or that's a $5,000 job. Software engineers, they do the same thing. Factors affecting productivity. The application domain experience, number one factor. The more experience you have in the domain, the better. If you're an internet developer and you're developing an internet application, you're good. If you're developing an embedded systems application, you might want to rethink the project if you don't have any domain experience, because then you have to learn, you have to basically get up to speed, and that's going to cost you. Process quality, project size, technology support, working environment. actually has an influence on it as well. And that page 20 is coming out of the textbook that I recommended, Systems Practitioner's Approach to Software Engineering. It's in the syllabus, if not the URL. Quality and productivity, all metrics based on the volume unit of time are flawed because they do not take quality into account. In fact, none of this stuff takes quality into account. I don't know how in the world you can actually predict the quality. You can do safeguards to protect yourself so that you can make quality as a goal, but you can't necessarily predict it, and you can't necessarily insure or charge for it. There's nothing you can put an estimate on that for. Estimation techniques, no simple way to make an accurate estimate of the efforts required to develop a software system. And actually, I don't even ask you anything about it. I just bring this in because it wouldn't be a Software Engineering 2 class without talking about it. But there aren't too many questions at all in terms of any of the final exam questions on estimating techniques. This is the part where I actually stopped on the weekday program because I didn't go through any of the algorithms associated with it. Because these are kind of considered junk science these days. You can read through it if this is brand new information for you in terms of different types of ways of doing the estimate. And again, it kind of models software testing in a lot of different ways of the top-down, bottom-up way of dividing the work out. What you're doing is you're doing estimates based upon you need this component, this component, this component, this component. Then you're mentally adding it all up and saying, this is the cost. Or you're taking, you have $10,000 that you're willing to invest, and then you start breaking it out. And that's the top down where you say, this is how much money. Okay, resources, this cost. Oh, we're done. Oh, well, half the program's not done yet. Okay, nope, can't do it. So you're verifying whether or not you actually, if that cost is going to be high enough to benefit the loss or to benefit the expense of the software cost estimation. So you can read through this to kind of figure out, some of the models and some of the traditional ways. In fact, don't spend too much time on the Cosmo model. It's very outdated. Still been around. It's actually been around since 1980, the 80s. If you imagine software development in the 80s, and you take a look at software development today, you have to imagine that the cost estimation, productivity estimates must be different today. The model has been revised. There's Cosmo 2. There's different versions of the Cosmo model. We're still working off the same concept, and what this is actually kind of doing is it's creating a formula for the complexity. Most software engineering companies that are successful create their own formula, and you come up with your own estimates. So. But that is everything I ever wanted to know about estimating, which hopefully you get the impression there's no science to it. There's theory, tons of theory, no science. No science at all. Questions about it? Not something that is heavily tested either in terms of this class. But I just thought I'd mention it. And I went over the same lecture in a lot more detail on the weekday program. If you have an interest in it and you want to hear more about it, go into the weekday section and you'll see it listed actually as software estimating. Spent maybe about an hour and a half or so on it. But I still didn't cover the Cosmo model because it's not really worth it, actually. So. Questions about Lecture 9? Because I want to get into software architecture next.
Object point analysis and function point analysis.
There is no difference.
What's the same thing?
It's the same concept. That's why I kind of skipped through it, because you're counting objects instead of counting function points. Function points in the old days used to be functions, which is where it got its name from. In the old imperative style programming, where we went from the top of the code to the bottom and we created functions, and when the execution jumped to this function, you called this function, and you called this function. You just counted up the number of functions, and you got a function point analysis. Object-oriented, you count the number of objects. But the only problem is it's not as accurate, because objects have more complexity to them, and it's a different animal than a function, essentially, because functions represent reuse. You write one function once, you call it many different times. Yeah, it's more of a function point. It's more of a it's measuring functionality. Objects is not. Objects is measuring interaction. It's measuring identity. It's measuring components. Some objects play a higher role, have more of a function in the program than other objects. So objects aren't really the same, but it's applied. Object point analysis is applied in the same manner, which doesn't really make it reliable. But none of those techniques are that reliable. Not even function point. Function point is a nice starting point that's commonly used because of all of the other metrics out there, it's actually kind of more realistic. Yes?
I heard about a technique which is like, we have been following that technique in a project which is like
Function point?
work breakdown structure. And basically I was into testing, so
work breakdown, that's project management.
Yeah, that's a technique for the estimation thing.
Yeah.
So we were not actually going to the function points and all that because that was a part of the development thing.
When you're creating a work breakdown structure, you already have a list of the work.
Yes, exactly. Yeah.
You're not, and when you're creating the function point analysis, you're coming up with the list of the work. So the function point analysis is going to happen long before the project management component. Until you actually have a work breakdown is part of project management functionality, and you don't have a project yet until you estimate it and cost it out. And then once you have your resources, you have a list of resources, you have the work breakdown, the task list, then you can go ahead and put it into a schedule, and then you can apply PERT CPM on there. Actually, you can find out, in a best case scenario, this is the shortest path to completion. And then you can print out Gantt charts, and you can actually do the whole project management part of it. And there's professionals that call themselves project managers who get certified by the body of project managers. Yeah. And they're not software engineers by no means. They are project managers.
Okay, and it's like one more question.
Totally different breed of person. Yeah. No, it's good. It's a good conversation. Yeah.
It's like, say we start a project, which will have development and testing both. So generally, see, as per my knowledge, 30% of the total cost goes into the testing.
Goes into the testing?
Is it right or wrong?
Let me hit that back as well. I would say that 50% of the cost goes into fixing it. And it takes twice as long to debug the code as it does to write the code. The testing component of it, unfortunately, if it's done correctly, you can't measure it because it's actually integrated into the development. So don't write on it. It's not a measurable component if it's done. If it's integrated into the development process and it's done as continuous, it adds a little bit of time to the regular cost estimates associated with performing all these tasks. But it's not. It's part of it. It's given to you automatically. So it's not an extra cost at all.
So do we have a defined technique by which we can actually estimate that testing resources should take this much of time or this much of cost?
The interesting thing about software, it's all in the plan. It's all in the methodology that you're using and in the way that you've planned it out. You could plan it out. The example I just gave you, if you mix testing in with the software development efforts and you make it part of the process, there is no cost for it. Yeah. Or you can say, let's not mix it in and do it at the last minute. It's kind of like when you plan to do anything, the worst planning gives you the highest cost. Like, I didn't do it in this order. Like, even let's say you're in your car and you're going to go grocery shopping, you're going to go run some errands. If you don't plan your route out, it could take you twice as long and cost you twice as much in gas than if you mapped it out. And I know, in a second. If you mapped it out and you estimated out everything correctly by distance, it was going to cost you less. Same thing in software engineering, actually. It's all about the development of the plan and the methodology that you're using. Sometimes it's even the language. Some programming languages that you select they're fixed. because you can't use a different language. You don't have a choice. Some of them, the nature of the project lends itself to a certain language. Other projects where you have a choice and you have different methodologies that you could use, the development tools, the support for the tools, the language influences how long it's going to take to actually implement it. And the experience of the programmers. If you have to retrain everybody, then it's going to take longer.
Yeah.
What level, what mixture, are you documenting everything? Are you learning from previous projects? All that stuff. Knowledge transfer, group knowledge, corporate knowledge.
Lessons learned.
Believe it or not, the lessons learned, all that stuff plays into the cost of that development project. Which is why, you have software engineers that are here today, gone tomorrow. And then you have companies that have been around for years. If you're gonna make it, past the first year or so, you're around. Because if you keep losing on every project, you're gonna fail. So the way you measure success is if you're making money. If you're making money, then you must be doing something correctly. Guessing correctly, I guess. Unfortunately, it doesn't lend itself to most traditional business models. It's a totally different animal. Any more questions on this particular lecture before we move into our last topic for today? Yeah?
Just add one point.
Okay.
In terms of estimation with the PM perspective.
Yeah?
My current project was earlier waterfall. Now they adopted Agile after the new governor. And then they wanted to do SOA on top of it. So now everybody's confused. Who wants what? PM has no idea. He comes, every scrum we have, he says, okay, how long are we going to take to do this?
And they can't even know.
He has no clue. So developers say, yeah, I'll take about 8-12 hours. I say I'll take about 18 to write a use case. Even we don't have any idea how long it's going to take.
Yeah, it happens.
Yeah, now, not only are you breaking down the whole thing in iteration, now it's service oriented. So, it's I don't know what to say. It's just.
We have been doing this for the last 6 years.
Long story short,
Yeah.
nobody knows. Look into a crystal ball. Invest in cards and those tarot cards and the crystal balls.
Yeah.
Yeah, we were always in a meeting room in front of the manager, and
Yeah.
he's asking how many hours. We're like, we'll think, we'll tell.